A very good afternoon and welcome to the Indie Global Waste Management Summit. We had a very good inaugural session and now we have, which was followed by another session, and now we have urban sanitation industrial waste, a very important subject in the given context of the present times when cities are bursting at the seams. I would like to now introduce to you Dr. Sridhar Babu, Director Projects, Hyderabad Metropolitan Water Supply and Sewerage Board. I would also like to introduce to you and call upon Vedaram Srihari Garu, Dean School of Energy and Clean Technologies, Nikmar University, Hyderabad. Welcome, sir.
Yeah. Thank you, sir.
And I would also like to welcome Sridhar Sappa, Lead, Environment and Compliance, Dr. Reddy's Labs. Sir, very good
Thank you,
afternoon
sir.
and welcome.
Thank you, sir.
I would now like to invite Shri Vijay Sai Meka, Secretary General, National Real Estate Development Council, Telangana Chapter.
Thank you, Venu.
I would also like to now call upon Shri Ganges Reddy, Founder and CEO, Blue Drop Enviro Private Limited. A very good afternoon, sir.
Very good afternoon, everyone. Namaste.
I would like to call upon Dr. Sri D. Sridhar Babu, Director Projects, Hyderabad Metropolitan Water Supply and Sewerage Board. Dr. N.V. Bhaskar Rao, Chief Environmental Engineer, AP Pollution Control Board. A very good afternoon, sir. Now I would like to call upon Dr. Vijay Singhal, former Chief Engineer, Rajasthan State Pollution Control Board, Advisor PhD Chamber of Commerce, Rajasthan, who will moderate the session. Now I leave it to Dr. Vijay Singhal, sir. You may please take over the proceedings.
Thank you very much, and very good afternoon to all of you. It's a privilege to be here on this virtual Indo Global Waste Management Summit, and the topic is really very important: urban sanitation and industrial waste, which is very dear to all of us, because in these times, in modern times, when India wants to become a global power, we will be the third largest economy in a few years from now, and we aspire to become a developed nation in 2047. Scientific management of sewage, industrial waste, and you know, solid waste is of paramount important. We all appreciate this fact because we have been to we are from this field. We understand the importance, but then there are issues which we'll discuss today and how we can really overcome those issues. Even from the public health point of view, these topics are very important because any mismanagement, any unscientific management of sewage and the solid waste or the industrial effluents can result into a serious pollution in the streams and in the groundwater, and it can spoil the soil. So we need to be very, very cautious. We need to have an approach where we are able to address these issues. Government of India looking to these issues launched a Swachh Bharat mission and also in a smart city a program where a lot of funds were made available, and these two programs have really helped to create a intensive awareness among all the stakeholders, be it the public or the municipalities or be it the technocrats like us. It has given the required funds to carry out the activities and the technologies also, and it has had a very positive impact. Things have improved a lot, whether it is treatment of sewage or handling of the solid waste or other aspects. But things are still, we are far behind, and we need to really act fast. The road is, very long, uh, you know, ahead of us, and we need to work a lot. Just to give an idea, just to give a perspective where we stand today, let me talk about the sewage. As per the CPCB report, we generate about 72,000 million liters of sewage every day, out of which we have a capacity to treat only 36,000 million liters. It means half of the capacity we have. Out of that capacity, in India, there are around 1,600 STPs, sewage treatment plants. Only 1,000 STPs are in operation. So you can see that number of operating STPs are quite less. And out of these 1,000, only 600 STPs are able to achieve the prescribed norms or the standards. And these STPs only represent a minuscule amount of water, that is 12,000 mld, that is only 16%. So in effect, we are only able to treat 16% of the entire sewage in the country, which is generated, which is meeting the standards. Let's not talk about the reuse of the wastewater, which is very, very poor. Most of the wastewater, even after treatment, is just, flowing the drains on the rivers. As far as solid waste is concerned, we generate around 160,000 TPD of municipal solid waste every day in the country, out of which we are able to collect around 95%. That is one of the very big achievement of India, that we are at least able to collect the waste, not littering on the street. But out of that, we are only able to treat 50% of the waste. 18% of waste is going to the landfill. Rest we don't know what's happening. So the picture is not very, good. It's not very happy situation. But then we need to do the unfinished job. When I come to the wastewater, suppose in case of industrial wastewater, still around 2,000 industries are in operation without installing any effluent treatment plant in the country. That's the data from the Center Pollution Board. It's not the data which I have taken from any other, source. So there's huge number of industries still there which are not able to treat the water. There are many common effluent treatment plants in the country where they treat the wastewater generated from the small scale industries. Total number is around 190, and 62 of them are not able to comply with the standards laid down by the Central Pollution Board. So the the issue of industrial wastewater is also equally important. Though the quantum of the wastewater generated from the industries may be less, but then its potential, its pollution potential and toxicity is much, much higher than the sewage. So in quantum terms, the sewage may be a bigger issue, but you see from the pollution point of view, the pollution potential point of view, the industry effluents also poses a very large issue for us. For the industrial effluents, ZLD or zero liquid discharge has been mooted as a solution mecca for the industries, that they should go for ZLD. And many of the industries has really gone, many of the CTPs has gone for ZLD. The issue is very high cost of RO membranes and subsequent treatment through the multi-factor operators. So the cost is very high. Industries are not able to operate these systems in given scenario, and we need to find some low-cost solutions which can really help the industries to recycle the effluent after they are treated. In case of industrial solid waste, I feel we are in a much better situation in the sense that most of the biggest streams of the industrial waste, we have gone for extended producer responsibility, whether it's batteries, whether it's used oil, whether it is plastic, e-waste. We have, now rules and notifications which will impose responsibility on the producer, on the manufacturer to take care of the waste which are being generated by them. So here the legislature has been quite advanced, and then we have adopted all the international practices as far as solid waste generated from industry is concerned. But in the liquid waste, the Water Act is a very old, legislature from 1974. We need to really revisit it, include all, the latest, uh, uh, a latest thing like the water management, water efficiency, recycling, use of secondary, treated wastewater, that has to be mandated as per the law. I hope we will do that. This panel discussions, we have eminent speakers here, and I'm really sure that after the end of this we will have many new things to learn from them, and hope we'll gain something which can be applied on the field. With these words, I take a short break, and would like to invite the first speaker from the panelist, Professor B. Srihari, who is Dean from School of Energy and Clean Technology, Nikman University, Hyderabad. Sir, I would like you to speak on innovative technology in waste management. Your institute has been in the uh, forefront
Yes, sir.
in dealing with these issues. Kindly go ahead.
Yeah, thank you, sir. Thank you very much for first of all, and thanks to Mahesh and their group for inviting me in this regard. And of course, the topic is very innovative, that is interesting, and especially it is a current scenario problem what we are seeing in the world. It is not only problem of India; it is the entire rest of the world also facing the same problem. That is the waste management. Okay, 20th century waste is producing in the form of a byproduct. But 21st century we are seeing the waste itself as a resource. So like these technological developments achieved in this area. So many researchers and many consultants are working in in this area to how to convert this entire waste into a useful product. For example, you can see the lot of solid waste is generating. Okay, so the Terry people, that means the Energy and Resources Institute, India, they studied and given approximately 62 million tons of waste every year producing in India. Okay, out of this, 43 million tons was collecting, and the rest of things you are not collecting. 12 million tons are being treated, and remaining 31 million tons are without treatment, they are disposing. That means imagine how much waste we are throwing onto the environment. Okay, under this, it is not simply a filling of low-lying areas. Generally, solid waste management concepts, if you go through, well, filling of low-lying area, that is last option. Many people are doing all the waste. So before that, what you can do is there are so many other methods people are identified. The 3R principle: reduce, reuse, and recycle principles. These principles have came into the force to the manage the waste. So under this context, we are reused the lot of material. Construction and demolition waste is reused as in the form of a constructional point of view, and so liquid waste after giving a treatment. And just now, sir told how much water is producing and converting it to a wastewater. So now people are thinking the wastewater has been converted, especially separation of sewage and sullage concept. This has been made some new innovation of the at least one third of the pressure on water treatment is reducing. Okay, so coming to the observing this entire solid waste, 7.9 million tons are hazardous waste. See, observe here, this much dangerous waste has been gone into the environment, means it causing a lot of problems. And 5.6 million tons of the plastic waste. So I'm giving the statistics for Indian scenario. Of course, if you compare with the rest of the world, this waste is very huge. Plastic waste management itself is becoming a very big problematic in the world. And apart of that, important thing is the 1.5 million ton, 1.5 million tons as the e-waste. So it has been generated into this. And recently, the Central Pollution Control Board has projected almost in the year 2030, the waste generation levels are going to increase in 135
We can't hear anyone. Hello.
Hello.
Yeah. Hello. We lost actually. We can't hear Professor Hari. Mr. Mahesh. There appears some technical issue. Somebody can please attend it. Mr. Venu, we can't hear anybody.
Sir, I think you can move to the next speaker.
Okay. So there's some technical issue. I hope we can hear Mr. Srihar again after some time.
Hello.
So,
Hello.
now I invite
Yeah, he joined.
Mr.
Yes,
M.
sir.
P.
My,
Bhaskar,
sir, is my voice is
Chief
audible?
Executive from AP Pollution Control Board. And as you know, AP Pollution Control Board has been.
Hello.
Hello. Hello, Mr. Srihari.
Yeah, sir.
Would you like to continue?
I am Srihari here. Hello. Some in between I lost the connection, sir. Hello.
Actually, we have very a sort of a time. I would request you to please come to the topic immediately, and each speaker will have around 5 minutes to speak. So please
Yeah, okay.
restrict your time limit and please finish your, talk early. Thank you.
I think the next speaker is started already. I think so, right? Am I correct?
No, he has not. He has not. You can complete.
So
Yeah.
shall I continue?
Yeah, please go ahead. Yeah, Mr. Srihari,
Yeah. Yeah, I will take 2 minutes to finish. You
Yeah,
know,
please,
already
please.
3 minutes are wasted. So from my point of view, I want to project these innovative technologies. So
Yeah.
first one is the actually segregation. Waste segregation is the important concept. So for that, smart waste bins have been recently. Hello, is it okay,
Yeah,
sir?
please go ahead. Yeah, we can
Yeah.
hear you.
Yeah. The smart waste bins have been recently and identified. Here, artificial intelligence technology is used because nowadays government what they did is they distributed so many cans for the segregation of the dry waste, and metals and glasses separately like that. But many people, many illiterates, they don't know, and many people they are never bothers which box they have to keep like this. So now these smart waste bins, what they will do is because of artificial intelligence, it is identify and it will segregate. So segregation, separation at the source itself is very, very important. Under this context, the smart waste bins are become popular, especially in Western, in the European Union. And same thing, even in India also we can adopt. That is
Okay,
one
it's
method.
okay now.
Another one is the waste level sensors. Nowadays, most of the area, number of trips, waste collection and transportation, this is the problem. So some area, the trucks, the dustbins will filling up very fastly. In another area, it will take weeks together. So that's why a type of sensors are arranging in these dustbins means we can identify so where it is going to fill. So automatically number of trips can be controlled. This is another one. So it's very recycle bin ultra I company has worked on this and they developed such kind of the recycle bins. Another one is the robots, recycling robots, some type of the especially separation segregation, because most of the people what they will do is entire waste they dump together. So when this kind of robots, they are identifying metal one side and non-metal one side, biodegradable one side. So like this, they are identifying. So such kind of the technology now is becoming a more popular, especially the Western countries. Okay, another one is the garbage truck weighing mechanism. This technique has been more popularized of the identify the truck's weight and calculating and filling up and transportation. So this is reducing the a type of cost of the people, those who are supplying, especially collection and disposal site people, working people. And recently, certain type of organization, that is pneumatic waste pipes, they are developed. In this pneumatic waste pipes technology, what they are doing is the high pressure air will be, or suction created through the pipes. Naturally, it is a certain type of community area it is going to work somewhere. So this is a little costly, but certain communities it is useful for separation of entire waste in a particular place. And another important one is the solar powered trash compactors. So this is the innovative method. So generally what happened is the compressing of the waste, okay, and reducing the volume of the waste is important. So in the collected bin itself is a type of a solar powered trash compactor will identify, and it periodically it will compress. So this method is making more successful and also useful for the reducing the volume of the waste. And last one, providing especially for the e-waste purpose, certain kiosks are being provided, and collection and valued persons have been paid. And India also, especially in the 5th June 2018, Insta Cash people also, they opened this kind of the e-waste kiosk and worked out this. So these are all the various innovative technologies adopted in the solid waste management. Of course, there is a lot of topics are there to discuss. Anyhow, sorry, sir, I think I might have exceeded my 6 minutes. I think so. Okay, I'm stopping at this stage. Thank you.
Thank you, Professor Sri Hari. So nice. I mean, you really wonderfully
Sorry, in
you
between I
mentioned all
lost
the new
connection for
technologies.
I lost connection for 2 minutes. Anyhow, no problem. Anyhow, these are all the good methods, sir. These are getting more popular. Once in future, India also, if you adopt, automatically we can manage the entire solid waste management in a useful project, and waste to energy conversion also becoming a more popular in future. So this is the my
Thank you.
version of the waste management.
Thank you, Professor. Thanks a lot. Thank you very much.
Thank you, sir.
Now invite the next speaker, Ms. Shri N.B. Bhaskar Roy, who is Chief Knowledge Engineer at AP Pollution Control Board. And
Yeah, good
I will
af-
ask you to- yeah, please.
Yeah, good afternoon, Mr. Singhal and other
Please go ahead.
participants. So just let me share some best practices in respect of industrial pollution control in Andhra Pradesh. Just I will try to be little
Please
bit
stick to the
fast.
time limit, Mr. Roy, because we have
Yeah, definitely. We have another
Yeah, please
company
go
of
ahead.
3.
Yeah.
I just put
Please
the
go ahead.
slides. Can okay. Okay. Can I? Yeah, is it visible? Yeah. So, pollution control boards are the regulatory bodies for implementation of various enforcement laws. Everybody knows it. So, first thing, what we did in Andhra Pradesh is because the main problem is with unorganized sector like stone crushers, pulverizers, rice mills. So, what we made was we developed some citing guidelines for 7 sectors so that the distance from the habitation, distance from the roads, etc., have been stipulated.
Mr. Roy, we
And
can't see the
minimum-
presentation. Mr. Roy, presentation is not visible.
Hello.
The presentation is not visible. We can only see the Google, that
Okay.
page.
Okay. Figures are smaller. Okay. Right. Anyway, I will be just
go ahead.
reading. No problem.
Yeah.
So. So such an arrangement has been done for the unorganized sector, and that we are implementing, so that at the establishment stage itself regulation is done, so that because very difficult to implement once they are established. So at the established stage we are trying our level best. The second thing is in AP we have you all know drug industry sector is one major sector. We have around 204 units, and the next is mining industries and cement. There are some cement industries, etc. So a good number of bulk drug industries really happen to be a big problem in the initial stage, and in the course of time we went up to the ZLD systems. Now they are under implementation. So especially in AP, in all 17 categories, and major polluting industries are monitored by PCB through randomized inspections, so that and real-time monitoring is also there. People will go from anywhere and they will inspect apart from the real-time monitoring existing. So they are further reviewed in the committee. We have a transparent committee so that if at all any lapses are there, whether to levy environmental compensation or to issue certain directions, so that initially we give some time, and if they fail to implement, then we may go after number of opportunities, we may go for stringent actions. So for hazardous waste, this is very important factor as far as industry pollution is concerned. The hazardous waste, we have developed one AP Environmental Management Corporation, separate corporation, where we have developed a portal, and through the portal, entire track of the waste management, where it is generated, how it is going, where it is, everything will be monitored. So this is visible to the all officers, and that way we are able to do something good. And second thing is, we are not allowing any non-biodegradable waste for the day after, even after treatment also, we are not allowing to be disposed on land or into rivers or any water bodies. So this is being strictly followed in AP since inception. And only biodegradable waste, if they have good treatment systems and if they meet standards, then only we will allow on land. That also they are not allowed disposal into the rivers or any other water body. So coming to the industries, chemical industries like bulk drug or so, we have overall 187 number industries operating in ZLD, zero liquid discharge system. And of course, we have 9 CETPs also. CETPs are established where there are a cluster of industries like Pharma City, etc. In some of the areas, Visakhapatnam and Nellore areas. So there we have provided common ETP, and we have 10 number of marine outfalls where mostly bulk drug industries are located. And here we have a protocol. It's not, they cannot simply discharge into the river, sea. That's not possible for them. We have a guard pond system where the treated water is kept in the guard pond, and a team will come, and the team also in oscillating one week one team, and next week another team. So these team will monitor the quality of the effluent, then they will give permission. Apart from that, there will be online monitor to the pipeline. So with this system, we have a good protocol. We are monitoring these 10 marine discharge industries, and developed SOPs for all discharges. And apart from chemical industries, in most of the other parts of India also, people are implementing for distilleries, ZLE systems with biomethanation plus the concentrated effluent to the biocomposting. These methods are also it is there. And this is the ZLE system normally we follow. And the next speaker, Mr. Sridhar, being a industry representative, I think he will explain in detail. But in brief is, the high TDS, low TDS, both separated, and low TDS effluents after treatment in the biological treatment and reverse osmosis, and the only RO reject goes to the high TDS part, and where high TDS part after stripping and both this effluent and that effluent will be treated in the ME, in multiple effect evaporator, and agitated with thin film dryer. So where ultimately a solid waste is generated, that will be sent to TSDF or co-processing, depending upon the quality of the solid waste. So this is being implemented all over the state in most of the chemical industries, because we are not allowing discharges. Next. So coming to real-time monitoring, we have developed real-time monitoring, and in the morning, our chairman sir also told that he is very much interested in the real-time monitoring, so that the quality of the effluent and emissions are monitored immediately. So in this context, we made the systems, and we are improving also. And we have developed SOPs for the real-time monitoring also. And wherever there is exceedances, the data is transmitted to the ABB's website, and alerts are also sent to the respective industries. Next. So these are the 17 category and red category where these real-time monitoring systems are existing. Next. We have two TSDFs. We have because we are not encouraging much TS. This transport, this disposal is the ultimate option, last option and least option. So we are not encouraging TSDFs, whereas we are encouraging the co-processing, pre-processing, and other waste to energy projects and other type of methods, so that even including cleaner technology concepts in some of the industries where the waste is used in another industry. So in that context, we are going with 2 TSDFs only, where the waste which cannot be used elsewhere only being used in the disposed in the TSDFs. And we have two waste to energy plants. They are very much effectively, because they are meeting catering to the needs of so many municipal corporations in Andhra Pradesh. About one is in Visakhapatnam around 1100 TPD, and another one is in Guntur 1200 TPD. So they are generating in each area about 15 megawatts of power. Even so a little bit wet waste also they can be incinerated here, by which power is generated, and this is helping the state a lot. About 40-50 municipalities are connected to these waste energy plants, and now we can say that our sanitation is better. And we have 12 cement plants where co-processing is being done. Coming to other things, we are extending the real-time monitoring to other units like edible oil units and aqua processing units and dairy units with wastewater generation more than 100 KLD. Plus, we are extending to all other areas where we feel it is necessary, because this monitoring is very much helpful. Instead of going inspections every day or every week, this will help to regulate the industry in a better way. And apart from that, the industries wherever boiler size is 10 TPH and above, they are also we are insisting for online monitoring systems. And ferroalloys, there is a problem, bypassing of through emergency cap happens. So that also we are providing a kind of system where emergency caps, whether it is bypassed or not, that can be caught hold of. And Form 3 separately, the Form 3 in the hazardous waste tools, that also we are making arrangement to get the data every day, so that we can just track the waste management in respect of hazardous waste. Apart from that, we are making a protocol for environmental compensation wherever the exceedance of emissions and effluent data transmitted is there, so that how already central board made some guidelines. Using that guidelines, the minimum compensation is around 5,000 per day. So after giving adequate opportunity, like chance for rectification of the momentary exceedances, that also will be given, and physical sample also will be collected. In spite of that, if there is no improvement, then only the environment levying is planned. So that this we are at to do, but we are on the at present only alerts are going and formal notices are going. Most of the people are there rectifying their lapses within the time limit and intimating to the board. So with this, I thank the all organizers for giving me the opportunity. Thank you all.
Thank you, Mr. Rao. It was a wonderful presentation. Andhra Pradesh Pollution Control Board is a very leading, pollution control board in India, and your actions you have taken are really commendable. Uh, you know, uh, uh, Thanks a lot. So the next speaker is Mr. Vijay Sai Mika, who is Secretary General for National Real Estate Development, a Council of Telangana chapter. He is also associated with Green Buildings. I request Mr. Mika to shed light on how do we manage, amount of management is done, especially with respect to sewage and solid waste in green buildings. What are the norms? How do they do it? Which are the good buildings which you can set an example from Telangana state? Please go ahead, Mr. Mika.
Yeah, thank you, Dr. Vijay Singhal, and thank you, the other panel speakers. The role of society and government, I think we have to separate it. The waste management in India, I think the sensitization is very poor. We are not understanding the consequences. And most of the people feel that it is the responsibility of the government to manage the waste treatment, though actually they use it abusively and throw it wherever it is possible. For in most of the cities, I think the population is growing, but the manpower actually to handle the waste is not phenomenally increasing. So this is where actually a big, massive awareness program is I think to be taken up by all the local bodies and all other NGOs and associations, so that the waste can be actually collected at the source and reduce the transportation. One way is actually another biggest threat for us is plastic. So if you're able to control or actually segregate the plastic at the source, suppose if there is a residential apartment complex where about 200, 300 apartments were there, if we were able to convince the residential association and the residents there to segregate the plastic at the source, so the transportation from there to the landfill can be avoided, and the waste that was actually the plastic that was generated can be sold by the resident welfare association, and they will also get some money out of it, because the plastic is the biggest threat that is actually causing concern to all the countries globally and also nationally, locally also. We have seen so many water bodies are actually choked because of this plastic that is going into the drain through the uh, waste, sewage waste into the lakes, into the canals, into the rivers, which we cannot actually collect it and process it or throw away. So this is a big menace. So like that, most of the residential welfare associations, if you are able to convince them and sensitize them the consequences of not properly manage this waste. The another important aspect is, if you are able to convince the resident welfare associations to convert the wet waste at the society level itself and convert it into manure, they will also get manure, and there is a big savings actually in terms of daily transportation of this waste to different landfills uh, all over India, because this is again a big threat to our environment. The landfills wherever actually we are using to store this waste is becoming a big health hazard to the neighboring villages and the residents. So India, I think we are very at a very nascent stage of addressing these issues and concerns, because among us, even the educated people also, the awareness about the consequences of the waste management and its hazards are not properly uh, communicated and addressed. Most of the times, actually, we feel that it is not our role, and the government has to take care of everything, which is next to impossible. Because if you take in Hyderabad, there will be few thousand people, sanitation workers are working in city for a population of more about a crore of people. So unless we become conscious and start actually acting on it, it is actually going to help, going to trouble us a lot in the long run, because for the next generation we have to actually give them a clean green environment, which is not happening now. And the biggest problem is this transportation of material from this about 50 to 70 kilometers throughout the city every day is becoming a big problem for most of the urban local bodies, because the waste is increasing day by day. As the population in city is increasing, the collection of waste is increasing, and it is also becoming a big problem. It is also becoming a big burden actually for the local urban bodies to collect so much from the source, and actually they have to actually take it to the starting point. From there, they have to fill it actually in the taking it away to 50 to 70 kilometers away from the city. So all these issues actually need to be addressed with a proper collective approach with the society, with the residential welfare associations, and with the local urban bodies, with the active involvement of the bureaucrats and the politicians also. Unless we sensitize and address this problem, it is becoming a big nuisance. I think most of you actually see our water bodies, they're contaminated. If you go to abroad, they were crystal clear because the society as a whole is sensitized. They'll not allow anyone actually to throw this waste into the water bodies. If you see some of the European countries where the water quality are crystal clear, it is more than treated water quality you will find in the water bodies. So we have to reach to that stage. Unless actually the whole society is sensitized, we will not reach that stage. Unless actually we started actually treating everything that is going into the lakes and canals. All our water bodies are polluted. The same water we are using for agriculture production, so the same agriculture we are consuming, so which is also a big threat to our health of the residents all over India. Thank you.
Thank you, Mr. Bika. You've rightly pointed out role of citizens in environmental management, whether it's a sewage or solid waste, and this of course needs to have awareness programs to involve all the citizens. Thanks a lot for your nice suggestions and your very candid, talk. I come to Mr. Sridhar Sappa, who is a lead environment compliance in Dr. Reddy's lab. He will share his experiences in achieving ZLD in industrial wastewater and new technology interventions to sustain the ZLDs. Welcome, Mr. Sappa. We'll stick to time limits because we're more speakers.
Yeah,
Thank you very
thank you,
much.
sir.
Please go ahead.
Sir, is my slide is visible, sir?
Yes, please go ahead.
Yeah, I would like to thank all the panel members for your valuable time, and I would like to thanks to Bhaskar Rao sir, who has given opportunity to the industries who can demonstrate their best practices in handling the waste management system. So in this panel, I think we are the only one industry who has got opportunity to demonstrate our wastewater management system. So before going to the presentation, I would like to tell something about our organization. So Dr. Reddy's is into the uh, various businesses like active pharmaceutical ingredients, formulations, and other IPDO business. But I would like to talk about only API part, because API is generating most of the waste. So I would like to talk about on the API business. So in Dr. Reddy's overall at India, we have a 6 manufacturing units, whereas 4 units are located in Telangana and 2 industries are located in Andhra Pradesh, which are at Paidippuram, Srikakulam region. So now, before going to the presentation, I would like to stress on the requirement of the ZLD and the new technology intervention in the conventional treatment process. And I would like to talk a little bit on the hazardous waste handling part. So I would like to tell to this forum that we are the first pharma industry who has established zero liquid discharge plant in the year 2004. From then onwards, we are successfully operating the zero liquid discharge. So all our effluent generated from the facility is being treated and reused back into the system. So before going to the ZLD concept, first I would like to tell that the success behind the ZLD is depends on the segregation of the streams. Segregation of the streams. In general, during our operations, various effluent streams will be generated from the different operations and process of the product. So, like our pharmaceutical industries generally have a reactions, filtrations, distillations, granulation, swifting. These operations will involve where the waste will be generated. So here the waste we have generated segregated as it two. One is a solid waste and second one is a liquid waste. Liquid waste is mainly consisting of aqueous layers, equipment wash water, and other equipment cleaning. So here we have segregated the effluent streams from the source itself. So we have taken the samples from each process of the product we have quantified and qualified, and then we have done the biodegradability studies. Based on those reports, we have evaluated the treatment scheme, which stream goes to the which treatment process. So generally, in traditional effluent treatment, ZLD involves stripper, multiple effect evaporator, HT thin film dryers, reverse osmosis plants, biological systems. So this is the typical zero liquid discharge schematic flow drawing. Here, based on the characteristics, we have divided our effluent streams as a high TDS effluent stream, low TDS effluent stream, and non-process effluent. High TDS effluent streams is nothing but the COD and TDS is more than 5000 mg per L. We have considered as a high TDS effluent, and below that we have considered as a low TDS effluent. And non-process effluent is nothing but the effluent generated from the water plants, softener regenerations, boiler bleed off, and cooling tower bleed off. These we have considered as a non-process effluent. For each and every stream, we have a different kind of treatment facility. For high TDS effluent stream, we have a primary treatment system followed by the stripper, and then multiple effect evaporator, and then agitated thin film dryer, ATFD. So basically, in primary treatment system, we have a equalization and neutralization. So generally, our various streams coming from the various production blocks have a different kinds of pHs. So we will equalize those effluent streams, and then we neutralize, so that that neutral pH can take care into the followed treatment facility. So after equalization and neutralization, we have a coagulation and then flocculation. At coagulation, we use polyaluminum chloride or alum as a coagulant, and polyelectrolyte as a flocculant. So after this flocculation, whatever the flocks form, that would be settled down in the primary clarifier. The primary concept, the primary treatment system, why we have introduced, because we need to remove the suspended solids, oil and grease, muck before sending it to the stripper. Otherwise, the stripper will get choked. So we will eliminate these oil and muck, suspended solids, and then the clarified water we will send it to the stripper. At stripper, we will give the steam, and we will increase the temperature up to stripper top temperature up to 95, and bottom would be at 105. Those top vapors would be again condensed back, and that condensate would be again reflected back into the stripper, so that the stripper distillate could be enriched with the solvents. No, we are getting 80 to 90% of solvent content in that stripper distillate. So those stripper distillate, we are sending it into the cement industry for co-processing. The stripper bottom will be treated into the multiple effect evaporator, where we have a
Mr. Sridhar, please bind up early. We have two more speakers. Do you want to elaborate the process? You can tell the basic idea what are the innovations you
Sure,
have
sure,
done. Yeah,
sure, sir.
please go.
So for low TDS system, we have a biological and then RO. RO reject is handling at low temperature evaporator. So here the entire recycled water is treated back into the utilities, and the solid waste generated from the ZLD is is sending back into the cement industry for co-processing. This is the typical effluent balance sheet with mass balance, so that we can understand that where the system is performing, how the system is performing. So this on monthly basis we are evaluating with this mass balance sheet. So the present treatment cost after introduction of new technologies, our treatment cost now is in between 900 to 1100 rupees per KL. So the variables as given here for the understanding purpose. So new technology intervention to sustain the zero liquid discharge. Here we have introduced the zero liquid we have introduced the low temperature evaporator in place of multiple effect evaporator. That I will speak in next slide. Multi-disc screw press. This is replacement for the traditional decanter centrifuge. So here the moisture content in the decanted sludge has reduced down from 80% to 50%, so that the solid quantity is coming down. And the energy, this is the highly energy efficient equipment. In earlier, we used to operate at 18 kilowatt. Now with this system, we are operating at 5 kilowatt per hour. So this is the low temperature evaporator, which is a green technology. This is a substitute for multiple effect evaporator. Now for RO rejects, we are handling with this low temperature evaporator, where the steam requirement is very minimal. In traditional multiple effect evaporator, the steam consumption is 350 kg per KL, whereas with this LTE low temperature evaporator, the steam consumption is 5 kg per KL. And this is also a high energy efficient system, because we are using multi vapor compressor. The energy consumption has brought down from 35 kilowatt to 24 kilowatt. So with this, in earlier multiple effect evaporator, our treatment cost is 1,000 rupees, 900 to 1,000 rupees. With this LTE, our treatment cost has brought down to 300 rupees per KL. And this is the new advanced oxidation process, which is under trials. This is the replacement for the biological system. Now, for biological system, we need a huge footprint. Whereas with this advanced oxygen system, the footprint is very minimal, because the residence time is 2 to 3 minutes. Whereas in biological system, the hydraulic retention time is 5 to 7 days. So this now trials are completed, and it's a little bit encouraging. With this advanced oxidation process, we got CO reduction up to 80%. So after implementation of this advanced oxidation process, our treatment cost may come down a little bit. So this is the SRS waste generation, where the waste generated from the different manufacturing processes, and how we have treated, how we are disposing it, which we have shown in this slide. So our entire hazardous waste is being disposed to cement industries, and certain waste we have converted into the byproducts like sodium sulfate and potassium sulfates. These we are selling as a byproduct. Thereby, our hazardous waste has come down. Biomedical waste has been is being disposed as per the PCB norms. When come to the air pollution control, for process emissions and ZLD emissions, for entire emissions, double stage scrubbers are in place. With all this, to summarize that, with intervention of new technologies and with effective, highly technical manpower, we have brought down our treatment cost, and we have sustained our zero liquid discharge process from past 20 years.
Thank you, Mr. Asridhar. I mean, Dr. Reddy's is a very, very environmentally compliant organization. I know you are also a green-rated company, and of course, you have used many, tools for your wastewater treatment, which are of, advanced, nature. Now, I invite Shri Ganesh Reddy, who is the founder and CEO of Blue Drop Enviro Private Limited. He is into nature-based, wastewater solutions, and he will talk about sustainable wastewater treatment systems. How treatment systems generally being used are not sustainable, and what we can do for that. Mr. Reddy, please go ahead.
Thank you, sir. I'll quickly share a presentation.
Please stick to a time limit, because we are short of time. Thank you very much.
Absolutely, sir. Can you see my screen? Is my screen visible? Hello?
Yes, go ahead.
Okay, all right. So typically we are talking about largely electromechanical systems that are being deployed all over the country. So these are the electromechanical systems, and these are the challenges. When you look at the large consumption of energy is a major problem for the climate today. So conventional systems do tend to take a lot of energy, and they're complex to maintain. These things are making systems not so sustainable when it comes to maintenance and operations. So we brought in nature-based solutions. Vis-a-vis, you can compare this versus that. Both are doing the same job, And these are highly engineered systems. It's not that they are some kind of just plants, trying to treat water, but they're highly engineered systems. Unlike surface engineering, we have deep surface aeration at the bottom of these navely looking wetland systems. To see, they will be looking like gardens, but at the bottom of these wetlands, we got some advanced engineered aeration that runs only for about 8 hours, which provides a very high level of efficiency, meeting the ammonical nitrates and nitrogen removal efficiencies mandated by NGT, with low energy and very low footprint for a nature-based solution. That today we are able to execute systems at a 0.6 square meters per KL. So 100 KL, I can implement it in about 60 to 80 square meters. So, if you see this one, the video shows you a good deal of understanding of how effective the aeration can be. While the bacteria and plants uptake the nutrients, the aeration helps removal of this nitrogen from the streams, ammonical nitrates, and also help see this aeration. Every inch of the space has got the aeration here. And these systems can be deployed for industrial clients, for domestic clients. The idea of bringing these systems into game is to ensure that people can adopt these systems, coexist with these systems, that they are order free, they're reasonably low maintenance, they take low energy, and they actually do the carbon sequestration very effectively. And of course, they reduce emissions when you take lower energy. So these kind of systems are the need for the country today if we are to sustain and maintain these systems with unskilled labor for 30-40 years. So these systems can be built from 1 KLD system I shown you above, and this system that below is about 150 KLD. We have done projects up to 2.4 MLD. We can build systems up to 10 MLD. So these kind of sustainable systems are the need for the day. The whole all over the world, the need for reduction of energy, reducing emissions has been very highly emphasized, and nature-based solutions are being adopted widely. In India, we are having huge information gap. So people are not getting to know that we can do a competitive job as much as conventional systems do. Of course, we can't do for ZLDs and all that when there are highly chemical contaminants, toxic waters. Then you have to go with chemical measures. But otherwise, anything that is biodegradable, it can be handled. This is one of the cases where we handled a flowing nala, really in a dirty shape, where people could not open their doors and windows for several years on the nala side. But within a few days, we were able to arrest the orders and fix the water quality, which you can see. This is a water body that we fixed in Hyderabad. This is a kind of transformation. Again, we followed the simple methods of enabling the food web within the water body. Even though sewage is coming every day, we do certain kind of enzymes. These are vegetable-based enzymes that break down the complex polymers, proteins into simply digestible, a matter for the bacteria that exists in the water naturally. And we aid this with micro aeration. All the aeration systems that we built with this nature-based solutions are micro aeration, low maintenance systems that provide for a great level of, efficiencies. So these are economical systems. When I show you these numbers, these are not expensive. They may be very similar on the capital cost, but the operation maintenance cost is 50% to 60% lower. A 1 MLD system costing you 3 crores on capital, here costing about 13 crores. These are the real numbers captured from the market, from the practitioners, where systems are being run properly. And our system costs you like 6 crores. So this is the kind of financial viability we have to bring to systems. When people can afford systems, of course, industries may have income, but a lot of other segments may not have as much income to constantly throw money at this. And a lot of people are not even aware that the systems take more money for maintenance than the capital. So, and when it comes to environmental parameters, this is what we are talking about. Not only we save money, but we save environment by sequestering the carbon, reducing the emissions, creating this opportunity for eco restoration and biodiversity. We contribute to 7 SDGs directly. So this is the kind of work that we have to do. I think these kind of projects will certainly help the society at a large, and for the industries, of course, in private and public. So this is a cement factory we built 1.2 MLD. The entire water, being of such a high quality, is being taken back into the process again, and it's a nature-based solution again. A guy who failed 10th class runs this system. So this is the kind of things that we are talking about when it comes to nature-based solutions. So my submission to the entire industrialists and people around is that somewhere this communication has to reach people. There are a few companies like us who are working across the country. Some are learning the game, and we have reasonably mastered these technologies that we integrated very advanced sciences. So we are competing with SBR, MBBR systems on the footprint. being a nature-based solution, and of course on the finances. So that's all I have as an introduction to my work, and I would be very happy to take any questions, and we'll be glad to hear get a feedback from you all.
Thank you, Mr. Reddy. Thank you so much. You have new technology on the horizon. It's not new entirely because I've been seeing it, hearing it from last 10, 15 years. But of course, implementation is not so widespread. But as you said, advantages are numerous, and we have to have a serious look at these technologies. So thanks a lot. Now, last speaker. Now I invite Madam Anita Agrawal, who is a faculty and head of Environmental Management Division of ESCI, Indian Staff College of India. She would like to speak on waste management in smart cities. So over to Madam Agrawal. Yeah.
Thank you, sir. Thank you so much for giving me the opportunity. Actually, my director, Dr. G. Rameshwar Rao, sir, was about to address this, but since because of his some urgent meeting, I'm there on his behalf. Well, I was hearing all the lectures, and I could understand many of the things about waste management in smart cities has already been spoken. So I will just give my experience, whatever I felt and I know about it. So yeah, my slide is here. Just a second. I can share from here video file, share screen. Okay. Is my screen visible, sir? Hello, is my screen visible?
Yeah. Not believe. Please go ahead.
Okay. So when we are talking
Make it
about
full
waste
screen. Yeah.
management, this I
Make it
will
full
take
screen.
first. Yeah.
Please make it full screen. Yeah.
Sorry,
Make it. Yeah.
is it fine?
Yeah. Okay. Go ahead.
Okay. So when we are talking about waste management, as all the speakers are already experienced one and they know, so mainly here we are on to waste to energy and fuel, waste to compost and wastewater we need to be treated, and recycling and reduction of C&D waste. And how our hierarchy goes, first we need to reduce and reuse at source only. Recycling, composting, waste to energy, and landfills. Landfills should be the last thing to adopt. Waste minimization and sustainable use, multi-use of products we should have. Processing inorganic waste to recover commercial valuable materials. Processing organic waste to recover compost, and recovering energy before final disposal of the waste. And then even if whatever amount is remaining, and when we are disposing it, it should be it should have safe disposal at sanitary landfills, which is having engineering criteria, so we must follow that one. And maximum of our smart cities are already following it up. Only thing at other units of other districts of India also we need to follow it. And these all are interlinked. When we are talking about waste management, it's solid liquid waste management system. These each and every component whichever is mentioned here, waste collection, secondary segregation, cattle set, it all these all things are interlinking and interconnecting method. As you can see here, tertiary segregation, processing storage unit, liquid waste management, drying unit, and it should go here. Everything is targeting office admin. Whoever is taking care of this waste management thing, they should be informed of each and every activity, and that's why we are calling it as a smart, because it can happen only through the smart ways. So that's why we are calling it in smart cities, how these things are taking care and how monitoring is being happening. Here, before going to smart cities components, this also I would like to show here technologies for conversion of waste to energy system. How we can have it? It is three types mainly: thermochemical, biochemical, and mechanical. In thermochemical, we can use the following process. Incineration is there. Sir was also in the earlier lecture, he was talking about the same thing. Plasma gasification, pyrolysis is there. In biochemical, biomethanation, fermentation, and then mechanical, crushing, compressing, pelletizing. In all these, when we are mixing it, then final one integrated solid waste management system is working out for any district or any area. Then smart cities. And now we will talk about here a little bit that how exactly in smart cities we are following this waste management system. Smart cities are the mainly innovative approaches to waste management where we have to create sustainable, efficient, and environmental friendly solutions. So first, our data driven decision making. Basically, each and everything related to smart cities and waste management, we are using IoT, Internet of Things, sensors to collect real time data on waste generation. In AP also, sir said that they are having their real time monitoring data for collection disposal, and this data is analyzed to optimize waste management routes, schedules, reducing cost and environmental impact. In each and every urban city, they are following this thing in their own way. Like in Ambikapur, they the people who are collecting the waste, they are having their small mobile system. In Telangana, whatever the trucks and all are there, one route is there, which has been monitored by GHMC. So like that, it is happening. Waste segregation and recycling. They are promoting waste segregation at source and encouraging recycling. Automated bins are equipped with sensors indicate. In India, I think automated bins are not much right now, but in Indore, I have heard that at some places automated bins are there. For this, I am actually not sure because a long time back when I visited that place, they were saying they are planning to have it. But right now it is there or not, I'm not sure. But in abroad, you will find it. Automated beans are there with sensors, which you will indicate whenever they are full and prompting timely collection. And recycling initiatives are integrated into the waste management system to reduce landfill waste. Then smart bins, as I told you already. Then waste to energy. Of course, because now we have to consider waste as a wealth. So waste to energy is very much important. They're exploring waste to energy solutions where non-recyclable waste is converted into energy and process. I showed you incineration, aerobic digestion, and other processes are also there. And this is also reducing landfill waste and generating renewable energy. Public awareness, in last lectures also it has been emphasized that public awareness is very much important. In some of the cities you will find, in some of the communities, like Hyderabad is very big city, so everywhere you will not find public awareness, but wherever in some societies, GHMC and our government is very much trying to emphasize on public awareness, and public is actually very much aware. In their balcony only they are having their composting system and all. So this kind of public awareness will mainly create in reduce, will mainly impact it only. It will be mainly effective when public awareness is there. And in Indore, if you go, because in some societies also you will see they are not segregating. Even if option is there, but they are not ready to segregate because they don't want to touch that waste, kachra of their kitchen because it feels dirty, something like that. But in Indore, when I went, people are willingly they are segregating it, and then they are putting it into the truck, which is having the two types of dry waste and wet waste and sanitary waste also. Basically in their waste truck, it is the three compartments are there: dry waste, wet waste, and sanitary or some hazardous waste is there, suppose biomedical waste is there, because in home you will find some injections and all also, so that also they are planning, they are doing. So public awareness is very much important, which I found which I find very rare in, but still it is going on. I'm sure within 5 to 6 years again it is going to be public will be very much careful about waste, because now since childhood we are teaching our kids that how to handle the waste. So I'm sure in next generation, at least even after 5 years also, we will be having more awareness on waste management, how to handle it, do it at resource only. So we'll be more, ZLD actually. And then monitoring and reporting, that is as I told, in urban cities already we are following it, and in Indore, like Hyderabad, how they follow it. Citizens can use mobile apps, online platforms to report issues to waste management, which is practicing in each and every area, every urban city, and some small cities also, like Ambikapur of Chhattisgarh, which I have seen. In Jabalpur, like source at segregation is not there, but whatever facility they are having, that also I found quite good. Transfer station was also very nice. And when it is going, there is, it is basically mixed waste concept is there. Their mixed waste is going on, then crushing and all mechanical kind of thing happening, and then they are creating as a resource. So, and when monitoring and reporting is happening, it is promoting transparency and accountability in waste services. Sustainability goals. Smart cities often set ambitious sustainability goals, including zero waste targets. Then collaboration with private sector, like in this, which I Jabalpur. It is collaboration with private sector only. I am forgetting the name of that organization. So in private sector, they are doing a collection, recycling, and disposal. Everything is happening with that. Then circular economy. Why we are calling it circular economy? Because we are throwing the waste and then it is coming back again as a wealth. So circular economy, it is helping us in not just reducing but in earning also. So it is aligned the principles of the circular economy, aiming to minimize waste generation and maximize the reuse of recycling of materials. Then conclusion is waste management smart cities is about leveraging technology, data, and innovative strategies to create cleaner, more sustainable urban environments. By adopting these practices, we aim to reduce environmental impact, conserve resources, and enhance the overall quality of life for us. And just I know you all might be already knowing, but still I would like to show you here. I think I have some minutes more. So in Indore, how exactly they are working. I have some more minutes, right, sir?
I think you can speak for a minute or so. Yeah,
Okay, just yeah,
yeah,
this
yeah.
only I was showing. See, sir, when I was talking that they are having 3 to 4 compartments, and how willingly public is coming for your
Right,
wet
right.
waste, dry waste, and this hazardous waste. Also here, also at one side you have sanitary napkins and all, and another side that needles and all will be there if people are unwell in their home. So this is the thing. And IEC, how they have created public awareness. And main thing I would like to point out here, main thing I like to highlight here, spot fine is there. Suppose they come to know one, they have a yellow color of jeep, right? They will do, they will keep honking, and they will come and they come to know that whether wherever waste they will lie, and if they come to know every point of at every point they are having camera. So spot fine is there. That is also working very nicely. When we are having fine, I think public will be more aware that time that we have to have a fine system also. So that is the thing. And public transport are having this waste bins and all. See, pilot project, firstly they started, then collection of waste in 10 wards, bin free initiative started, D2D collection, then again bin free city. So like that, first as a pilot basis they started it, and they call them Safai Mitra Abhiyan, Suraksha. With good names they will call, they will give respect to each and every person who is involved in that. So that also matters a lot actually. See how they are having this thing. Oh, smartwatch, and they are keeping eye everywhere. So this is actually in smart city we are having, and in Indore already we are practicing, and I am sure in multiple cities of India we are practicing the same thing. It's just all over India, at every district it is not there, but I'm sure it will be done soon. So this is from my end. Thank you so much.
Thank you.
I want to
Uh,
put it.
Thank you, ma'am. You have really wonderfully informed us how data-driven approach and use of technology, good monitoring and management can do wonders, as in Indore and Ambikapur, which are leading lights in municipal waste management. Thanks a lot. And on this now, I have time is already over. And though I wanted to have more discussions with the panelists, such eminent panel, I thank all the panelists to be here and really sharing their thoughts. And now I hand over to Mr. Vinu to do the honors. Thank you.
Thank you, Dr. Vijay. It was indeed a very interesting session, and we've got very diverse views at the same time. Very complex issues were put up in a very, very simple manner. For instance, you know, when someone said, or for that matter, when Nigmar professor said, the 21st century waste must be seen as a resource. We've been hearing this, but when I heard him, it came like a breath of fresh air. Then we had Ganges Reddy sir saying, "No, the kind of work that they are doing is incredible, but the problem is there's a huge, huge, huge information gap." And that really, complements the another view which Anita Agarwal madam was talking about. And one reason why Indore is standing tall is because of this awareness and step by step process that has happened over a period of time. As they say, the Rome wasn't built in a day, and it was a very beautiful, strategically conceived idea of taking this particular concept to a particular logical end. It was indeed a very wonderful session, And now, from Indie Global Media, on behalf of Indie Global Media, we would like to give all our speakers, handover speakers, a token of appreciation, a certificate. And first, we should give our moderator, Dr. Vijay Singhal,
Thank you. Thank you very much.
who really managed the time and also gave a beautiful perspective initially. Sir, thank you so much. It was really helpful.
Thank you.
The next, we would like to give to Mr. Vijay Sai Meka, sir, Chief Environmental Engineer.
Thank you.
Yeah. Next, to Vedam Srihari, sir.
Thank you, sir. Thank you very much.
Thank you, sir. It was nice listening to you. You're very
Yes, sir.
enthusiastic and very clear.
Yeah, okay, sir. Thank you, sir.
Ganges Reddy, sir. Sir, please accept our wishes for
Thank
the
you, sir.
wonderful job that Blue Drop is doing. To Mr. Bhaskar, sir.
Yeah, thank you. Thanks a lot.
Thank you, sir. It was very interesting to know. It was very in-depth analysis, how you explained how the work is going on in Andhra Pradesh. And finally, we would like to give the token of appreciation to Anita Agarwal, Faculty and Head, EMD ESCI.
Thank you, sir. Thank you so much.
Venu, I would like to have the contact details of Anita. I would like to get in touch with her.
Sure, sir.
Yeah, you can please share.
We have a researchal project on the back of your office, where actually we can implement some of the initiatives you suggested for waste management.
Sure,
Is there
sir.
any other
Shall I share here, or I can share with India?
You can always share it with us and we will forward it to him as well.
Yeah.
Since we
So
are
I'll
running out
share
of
with
time.
In
India
fact,
Global.
all the
With
PPTs
Mahesh,
can be shared so that anybody wants to use them. All the PPT can be shared with all the speakers, so that will help
Yeah, sure.
people
Sure,
to.
sir. Sure.
Okay.
Okay, sir. Thank you,
Thank you
sir.
so
Thank
much,
you.
sir.
Thank you so much. Thanks,
Thank you.
everybody. Thank you.
Thank
Thank
you,
you, sir.
everyone.
Thank you. Bye bye.
Thank you, sir.
Thank you.